This video covers the explanation and use of the various model parameters for SRH located in the model control in the SMS interface. This includes time controls, initial conditions, and output controls. We'll start with a project that already has an SRH simulation built. Next, we'll right-click on the simulation item in the Project Explorer and select Model Control to view and edit model parameters for the simulation. In the Model Control dialog, we see the various options for the general parameters. The simulation description is optional and is generally used for noting information that may be useful later when reviewing the model. The case name is the key word that SRH-2D will use to link files together for the same case. A result of this is that the case name appears in the name of each SRH-2D output file generated for a specified simulation run. For steady-state conditions, where boundary conditions are constant, it is appropriate to assign the start time to be 0. However, when using time series for boundary conditions or other data, the starting time may need to be adjusted so as to meet those time specifications. The end time will determine the duration of the simulation. For steady-state models, the duration should be long enough for the model to reach convergence. For simulations using time series, the simulation should include a sufficient amount of time before and after the peak flow to adequately represent the range of flows. The time step value is the model computational time step. It is a critical value as it influences the model's convergence or ability to reach a solution. When the SRH model runs, the amount of time it takes to finish is largely a function of the mesh size, model duration, and time step size. A larger time step results in a faster total runtime since there are fewer total time steps in the simulation, but the time step needs to be small enough for the model to reach convergence. An SRH-2D model has converged when the iterative numerical processes have produced an acceptable solution. Convergence can be observed in a solution when the water surface elevation results are nearly constant between time steps and continuity satisfied. Satisfying continuity means that mass is conserved and that there is very little numerical mass loss in the model. The volume of water entering the model is accounted for in storage and water exiting the model. It is recommended to include monitor lines and monitor points at upstream and downstream locations to confirm continuity and indicate that a steady-state solution was reached. These are specified using SRH-2D map coverages, which are linked to the SRH-2D simulation. We will come back to them once we are ready to run the simulation and look at results. Because the time step is a critical value, we will perform a practice problem where we estimate an appropriate time step for this model. The time step is dependent on the element sizes used and the hydrodynamic conditions being modeled. We will use the current condition equation, dt equals length over the square root of gravity, to determine a good estimate of our starting time step. Using the measure tool, we will measure the length of the smallest element in the mesh, which we find to be about 4 feet. A length of 4 feet gives us a time step of about 0.5 seconds. It should be noted that the current condition does not need to be satisfied for a model to converge, and a larger time step may be acceptable as long as continuity is met and the solution is stable. The initial condition has 4 different options: dry, initial water surface elevation, automatic, and restart. The dry option will start the simulation with a dry mesh and is the default option with SMS. This option works well and is recommended for most cases. The initial water surface elevation option starts the model off with a constant value for water surface elevation over all the elements in the model. Elements whose elevation is greater than the constant value will be dry. The automatic option will fill the domain to the specified exit H water surface elevation if a constant water surface elevation is defined. Lastly, the restart file option allows you to choose a restart file from a previous SRH run on the same mesh. SRH-2D saves out a restart file at each output interval as specified in the Output tab of the model control. One of these restart files can then be used as the initial conditions of the model. This is useful for those simulations which take a long time to run until they converge. The restart files are saved by default in the SRH-2D folder, which is found with your model files, and are identified with the convention of using the case name _RST number. The number on the end is the output interval that the restart file corresponds to. We can therefore choose a restart file from any point within the previous simulation run. We will use the dry initial condition since it suits our purposes for this instructional video. The Flow tab has the option of changing the turbulence model that SRH uses. By default, the parabolic model is chosen with a value of 0.7 for the parabolic turbulence. The laminar option is suggested for use with flumes or lab conditions where laminar flow exists. The constant option uses a constant eddy viscosity, and the KE option is used to account for effects like convection and diffusion of turbulent energy. For most applications, these options can be left at the default option. The Output tab contains parameters that define how the solution data will be formatted. The result output format has options for XMDF, XMDFC, ParaView, SRHN, SRHC, and TechPlot. For the purposes of using the SRH model with SMS and for post-processing, the XMDF format is ideal. The other options are available for those modelers who would like to post-process the SRH results outside of the SMS interface. The Output Unit field needs to be consistent with whatever unit convention was used to construct the model. The output method can be set to either a specified frequency, specific times during the simulation, or just at the end of the simulation. It is important to note that the output time step, or frequency, does not affect model convergence. This option simply specifies when modeled solution data are saved to output files. Specified times can be useful when there is a specific point in time that you want to compare computed versus observed data. Using this option, we would populate a list of times for which the results will be output. The specified frequency option is the time interval that the simulation saves out solution data. When selecting an output interval or output times, there are a few factors to consider. Less frequent output results in smaller files and requires less disk space, but more frequent output results in greater detail. For example, if you were to generate an animation of the solution data with SMS, more frequent output would result in a smoother video. Another reason for utilizing more frequent output is related to model debugging. If a model is crashing, observing velocity and water surface elevation results immediately before the crash can help identify and evaluate the problem. For this model, we will use an output frequency of 5 minutes, or 0.0833 hours. We will now run our model and then view the results. Because we have specified the use of monitoring points, we see that once SRH-2D is open and running, that a plot window also appears showing the results at each monitoring point as the simulation advances. From this plot, we can understand the simulation's progress, as well as the steadiness of the solution. Once the simulation has finished, the solution datasets are then imported to display on the 2D mesh. We can see for a given solution dataset how the contours are changing as the simulation progresses, but then gradually they reach a steady state condition. This is to say that there are several output time steps for which we see no change in the solution, and that inflow is equal to the outflow. If we open a monitor line's output file, indicated by the LN at the end of the file name, we can see that the results converge and become stable towards the end of the simulation. This concludes the Selecting SRH-2D Model Parameters video. Visit the Federal Highway Administration's website or the SMS wiki pages to learn more.